Okay, gang, this is just a short presentation on the stuff that we're going to be talking about in section 2.1. And let me just say that in sections 2.1, 2, and 3, it's going to be a review of stuff that you've already done before in probably your pre-calculus classes, maybe even your Algebra 2 classes. So what I would suggest is, since we've got a lot of calculus stuff that we've got to get to, if any of this stuff seems a little bit foreign to you because it's been a while, I would definitely review these kinds of things, okay? So for example, in section 2.1, we review the concept of functions. Remember, functions, gang, their importance is due to the fact that they represent the reliance of one quantity on another, or the dependence of one quantity on another. You've seen them before. Like, for example, look at the formulas of your old math books, the front cover, like area, for example. Area of a circle is pi r squared, right? The area depends on the radius. That's like a function, okay? That kind of stuff. Function, it just denotes the dependence of one quantity on another quantity. They figure prominently in our business calculus class, so section 2.1 is going to be a good review of those things, okay? But first, a little bit of examples. So I picked a couple problems out of your book here, and I'm looking at, for example, number 12. And they give us the function f of x Okay, now again, if you recall, now this is when the function is defined in pieces like this, we call it a piecewise defined function, okay? So what they want us to do is find the following. Okay, so remember, the functional notation means whatever the numbers are inside of the parentheses here, you want to force those into these expressions here. But you have to be careful, gang, right? There's stipulations on both branches, on both pieces rather. The function is equal to this thing as long as you stay to the left of 2. Whereas as soon as you go to 2 and beyond, you're going to be using this piece of the function, okay? All right, so notice that negative 2 fits this inequality. And so we're going to be using this piece. Whereas this one right here, right, 4, that fits this inequality. And so we'll use this piece. Okay. At 0, that's less than 2, so we'll use this piece again. Okay. After that, it's going to be straightforward calculations. Okay. A little bit later on in the problems, now they ask us, for example, in number 24. Right, exercise number 24, it says, find the domain of the function. In fact, gang, in exercises 23 to 36, they're all like that. Find the domain of a function. Okay, you got to remember what the domain is, though, right? What's the domain of a function? The domain of a function, gang, is all the values that you can input into the function and get a real number back. So when we say get a real number back, we're saying, like, no division by 0, right? No 0 divided by 0, no negative numbers under square roots, you know, that kind of stuff, okay? So in number 24, right? Right, they give us the function 7 minus x squared, but that's just a polynomial. If you remember from your pre-calculus days, gang, polynomial functions, they are defined everywhere. And so therefore, the domain of a polynomial function is all real numbers, okay? Notice how I wrote the solution in interval notation. That's pretty much the convention we use in calculus now, instead of inequality notations, okay? Now, a little bit later on in number 28, not too much later on, right? They give us a function, they say g of x is equal to the square root of x minus 2, okay? Now here you've got to be careful, right? It's a square root function, and we know that you can't have negative numbers under square roots. So here's what we need. Make a note to yourself when you're doing this, okay? If you got a square root function, make a note to yourself that you're going to need, in this case, the x minus 2 to be greater than or equal to 0, okay? Because you can't take square roots of negative numbers. You can take the square root of 0, that's okay, right? So that's why I've got the equals right here. That's legal, okay? Solve this inequality by adding 2 to the other side, okay? So again, we say that the acceptable values of x that we can force into this function are all those numbers that are to the right of 2, including the 2. In interval notation, though, it looks like this. Okay, so that's the domain of our function, all right? Number 31, here they give us, now here again, you've got to be careful because you've got a fraction. And remember, from our experiences, we know that we're not allowed to have 0 in the denominator. So what values of x are going to cause this denominator to equal 0? In other words, what number can you force into the x? Square it and get a 1 back, because then you'll have 1 minus 1. Now, if it's not obvious what that is, go off to the side, go off to the scratch paper, maybe over here. Actually set your denominator equal to 0, okay? Solve this equation. Okay, so what that tells me then, gang, is that the values of x that are going to make the denominator equal to 0, and therefore the whole fraction undefined, are going to be 1 and -1. That's it, though. Any other number you can plug into this and it's going to work. You'll always get a real number back, okay? So the domain for this is all real numbers except these two. In interval notation, it's going to look like this. So, I apologize, gang. This is our makeshift classroom right now. Okay, this is the best I can do. They're not letting us go to the campus, so I am in my bedroom, literally. And this is the whiteboard that I borrowed from the campus. All right, so I hope you can bear with me as we go through this. Because of the whiteboard being so small, the presentations are going to be kind of short, but we'll do the best we can. Okay, I'm going to cut this one off, and then we'll start another one. Okay.